Welcome back, everybody. I thought you guys could maybe use a little bit of help on some of these homework 10-4 problems. This is on inelastic collisions. Now, this is going to be problem number 3, actually. So homework 10-4, number 3. And now keep in mind that inelastic collisions are collisions in which the objects don't bounce off each other perfectly. If we were to look at an elastic collision, that's like having an 8-ball, a billiard ball right here, smack into a 3-ball. I think they're red. Right here like that. Okay. And so the 8-ball is moving forward and it runs into the 3-ball, and then the 8-ball stops. There's our 8 right there. Sorry about my drawing. The 8-ball stops, and then the 3-ball continues on. That's and I need to be careful how I say this. That's an elastic collision. That's our 3, and so that moves on. It's elastic because all the momentum is transferred into the other object. Okay, that bounces right off. An inelastic collision, so inelastic, is a collision in which the two objects don't immediately bounce off each other. You might say the one object maybe sticks to the other object. So say we have maybe a piece of gum, like freshly chewed gum that somebody throws across the room, right? And a block right here. Well, the gum sticks to it such that now there's a gum stuck to the side of the block. That whole system is moving together. Okay, those are two different kinds of collisions. Either way, we say that momentum is conserved. This is the whole overarching principle here. Momentum initial, or you might say the sum of all the momenta initial, equals the sum of all the momenta final. And you know that momentum is comprised of mass and velocity, so that's saying the sum of all the masses and velocities initial equals the sum of all the masses and velocities final. Okay, so that's a principle that's gonna guide number 3 right here. So we have a bullet fired at a block of wood, so this thing is just flying through the air right here. This is the actual start of our problem. Okay, that's flying at some high rate of speed, and here is the block of wood right there. And let's see, we have this collision here, so pow. Okay, and after the collision, we have the block of wood, which originally was solid, but now it's got kind of like a hole through the middle of it, right? Because the bullet passed right through it. There's our block of wood with a hole, and there's our bullet going out the other side. Still traveling, but now the block is traveling as well. Okay? Immediately after the bullet exits the block, the speed of the block is 23 meters per second. So let's start labeling this. So the mass is 4 grams. All right? Wow, the mass of, I'm going to call it B for bullet and W for wood block. That's how we can tell them apart. So mass of the bullet is 4 grams. If we convert that to kilograms, that'll be 0.004 kilograms. Okay? And the velocity, or the initial velocity of the bullet, is 650 meters per second. Okay, and the wood has a mass of the wood, so that's what the W is. Mass of the wood is 0.095 kilograms. 0.0, so you don't need to convert anything. 95 kilograms. And what's the initial velocity of the wood? Well, that's easy. It's 0 because it's just sitting there. Okay, that'll come in handy later on. So then they hit each other, and we have this collision, and the bullet travels through, but also starts making the block of wood move. So the speed of the block, which by the way we're assuming is going to be the same mass before and after, we're ignoring the fact that maybe a little bit of this material has been removed. We're going to assume that it's the same velocity, same mass afterwards as well. The speed of the block afterwards, velocity final, of the wood block, I should say. I should put my arrows over my velocities here. Is going to be, what is it? 23 meters per second. And by the way, this, what I'm drawing right here, is probably a good way for a good habit for you to get into, of drawing the beforehand of one object, the beforehand of the second object, and then kind of like a clear dividing line here, and then the afterwards of the one object and the afterwards of the other object. Okay. And I think what we want to find is the final velocity of the bullet when it exits the block. Okay, we're assuming the masses haven't changed, and the only thing we don't know is the final velocity of the bullet. Well, remember, if we're conserving momentum, it's like saying the cumulative momenta beforehand have to equal the cumulative momenta afterwards. So all this is momentum initial, and all this we can find momenta final, or we can state it as momenta final, and then use it to solve for this final velocity here. So momentum is, the sum of the momenta is mass of the bullet times initial velocity of the bullet. Okay, we're going to add that to mass of the wood block times the initial velocity of the wood block. That's easy. That's going to become all 0. Okay, equals mass of the wood block times the final velocity of the wood block plus mass of the bullet times the final velocity of the bullet, which that right there is what we actually want to solve for. This right here is what we need. Hey, we actually know everything else. So let's solve for this. Let's solve for the final velocity of, I should say, the bullet, the B right there. Okay? So let's start by adding this to the other side. So that's going to be mass of the bullet, initial velocity of the bullet. Okay. This whole thing goes away. We don't need to worry about that. So we're subtracting this to that side. Minus mass of the wood block times the final velocity of the wood block. And then what do we do to get this mass of the bullet away? Well, we divide it. So that's going to be divided under everything here. Mass of the bullet equals our final velocity of the bullet. Pretty straightforward, right? Total initial momentum equals total final momentum. Well, let's just plug in and see what we have here. And you know what? I don't even have the answer. You'll probably have to wait for me to calculate it too, because I don't have it. Mass of the bullet. What is that? Oops, I forgot this dot right there. 0.004 kilograms times initial velocity of the bullet. That is 650 meters per second. Okay, minus mass of the wood block. That's 0.095 kilograms. Times what's the final velocity of the block? 23 meters per second. All that divided by mass of the bullet, 0.004 kilograms. Where's my calculator? Four times 650 minus 0.095 times 23 equals divided by 0.004 equals 103.8 meters per second. And that right there, my friends, is our final answer for part A. This is part A right here, I should say. Probably don't have enough time on this video for part B and C, but I'll look for you in the next videos and we'll address them then. Thanks for watching.